Hi everyone, today we're going to talk about the topic called as polymorphism. So let's understand what polymorphism is all about. Polymorphism is one of the most important or the fundamental concept in object-oriented programming, right? It allows the object to take on multiple forms. It refers to the ability of a class to have multiple methods with the same name but different parameters or behavior. So the word poly means having multiple forms. Same concept, having multiple forms. So in the case of object oriented programming, it basically gets converted into that you have a method which has, same name, but the behavior may be different, or the parameters or the inputs which you're passing to the function is going to be different. So that is what polymorphism is in Java or in any object oriented programming language, right? So in Java specifically, we have two different kinds of polymorphism. One which is called as the compile time polymorphism, or it is called as static polymorphism, and the second polymorphism is called as a runtime polymorphism. So we have a static polymorphism and we have something called as runtime polymorphism. The words of static and runtime actually are given because when you say static polymorphism, the form or the which kind of method or which method which will be called or will be executed is decided at the compile time. That is why it is called as the compile time polymorphism. And when the method to be executed is decided at runtime, it is called as runtime polymorphism, right? So that is why what the words runtime and compile time have significance here. So let's write the polymorphism, right? So as I hope everybody knows that the word static, when we use static keywords, it is basically always, evaluated at compile time. So that's why it's called compile time or static polymorphism. Now, when it comes to methods, right, we are going to do polymorphism because we want to have different behaviors for the same methods. Okay. So static polymorphism is achieved through method overloading, and runtime polymorphism in Java is achieved through method overriding. Okay, method overloading, let's talk about this. Method overloading is nothing but it is where you have same name methods, okay, but the difference is method overloading is done by having different method signature. It is done or achieved via having different method signature. Now what does method signature mean for people who are new to this concept? Method signature actually consists of the part where you name the method, right? What is the return type of the method and what all parameters and what are the data types of those parameters for that particular method. All these three things constitute the signature of a method. So you can achieve method overloading by doing what? By doing different variations of this method signature. That means you can have difference in number of you can achieve method overloading by doing variations in number of your input parameters, all right, or else it can be done by having different types of input parameters. When you mean type, that means data types. And third is you can do a variation of both. You can have the above both, right? You can have method overloading by having different parameters also, and also you can change the data types. By these three ways you can achieve method overloading. For example, if I take an example, I have a particular class called demo, right? Let's take some method. Let's say the name of my method is fun. Okay, I have a return type of void. Okay, let's say I have a parameter 1 which is of type integer, and there's something which I'm doing here, right? For the same class, I can have one more function with the same name, right? And here might be I do not give any parameters, right? So what I'm having is I am having a same name function, right? But here I have a parameter and here I do not have a parameter. That means I'm achieving the method overloading by doing what? By opting the first option, by making changes in the number of input parameters, right? As if there is one input parameter and here there is no input parameter, right? I could also achieve method overloading by also changing the, basically what? The type of my input parameters, right? That means I can have one more function here, right? Let's say void func, and let me say make instead of integer, let me have a double. right? So now in this method, in this particular version of method overloading, what I've done is I have overloaded the main method fun by actually changing what the data type of my input parameter, right? So you can have your overloading based on two things. Either you change the number of input parameters, or you can change the data type of the input parameters, or the third thing, you can do both the variations to achieve your method overloading concept. Just make sure method overloading happens at compile time. That means whenever I create an object of this class demo, right? Let me say I create demo d, okay, equal to new demo. Now when I'm saying the way I call my function, right? If I say d dot fun, right? Let's write, if I write d dot fun, this is one. Let's write the second one. Let me write it down. That makes more sense. So I'll say d dot, let me say we've already created the object before. So I'm going to write the first thing is d dot, let's say I can fit it in one screen. So I'm going to say d dot fun, right? Let's say the next call is d dot fun 2, and the third one is d dot fun, let's say 3.5. Okay, these are three different function calls. Let's say now this of which function or which method or the which version of this fun will be called will be decided during compile time. How? Because when you compile this, the first call when you see d dot fun, this does not have any input parameters. So the method signature which matches this is going to be this one. So this particular version of the fun method will be called by the first call. In the second call, d.fun2, what we have passed is, we have passed an integer value. So this signature matches with this version, okay, in our definition. So second call is going to basically call this version of our fun, which has one integer. In the third call, we are sending a double. Now this way, we are having basically matching with this definition. So the third function call is going to call the method of fun, which is going to be what? Sending in an input parameter, which is of type double. Okay, now when you're doing method overloading, please remember one thing: you cannot overload the methods on the return type. That is not allowed. You cannot overload on the return type, and you also cannot overload on the static keyword. So on these two things you cannot overload. What does this mean? In fact, this is also an interview question. So please remember, you cannot overload methods based on the return type, and you cannot overload methods based on the static keyword. So what does this mean? Suppose I have a function here, void fun, okay, and let me say I want to do method overloading, and if you say instead of void, I'll keep a return type as integer for this function, and you would say that I have done method overloading. So this is not allowed, because you cannot really just change the return type and say you have done method overloading. No, if you want to do method overloading, either you can change the number of parameters, or else you have to change the data type of the parameters, or you can use a combination of both, but just doing return type not allowed. Then the second thing is, suppose let's keep this as void, right? Now the only change we want to do is, you want to add one method as static and another method as non-static, and you would say that you want to do this method overloading. So this also does not work. Okay, that is what we said. Method overloading cannot be done on return type or on using the static keyword, right? So this is what is happening for your compile time or static polymorphism. Why static or why compile time? Because the which method to be invoked is been decided when you compile the code, right? Because when you compile the code, Java compiler, we can understand, be looking at the method signature, which one it has to call, right? So let's then talk about the runtime polymorphism, which is basically the interesting part, and it is called as method overriding. Now this feature of object-oriented programming in Java is basically allows you to have different behaviors, or in other words, different implementation for the same method signature. So you can have methods, you can have two methods which have exactly same signature, but what will be different is the different will be in the implementation part, right? Might be in one part of your implementation you are trying to print the values, say 1 to 4, and might be in another implementation you might want to print the name of your some string, you want to print the name. So you can have different implementations, and the which method or which version which will be called is dependent or decided on the runtime. This is our overriding concept. This overriding concept is usually used in our inheritance. You must know what inheritance is, or what is subclass and superclass relation, right? when you have child and parent relation, right? So when whatever method or whatever functionality you have, mentioned in the parent class, might be you want to make some changes when you are in the child class. Like for example, suppose if I have a relation like this, animal is the parent class of, say, child, of the child class cat. So cat is the child and animal is a parent. Might be I have a method here. Let's say the method is to create some sound. Okay, so let's say animal creates some sound. Now for the parent class, the kind of implementation I want would be something different than what I would want to create a sound for my child class, right? So in this case, because it is because it is inheritance, whatever signature you have, right, whatever method you have in your parent class, you're obviously going to inherit the same method in the child class, correct? You will have the same void. Let's write something here. Let's say this is system.out.println. Let me say that I am present in the animal class, just a demo, right? So this particular method, void create sound, will be available in the cat class. Why? Because inheritance is going to make sure that all the data members and the methods which are the parent class are available to the child class, right? So you actually will also have access to this sound class of the parent. But let's say you do not want the implementation which is there. What is the implementation in the parent class? System.out.println, simply saying animal. Might be you want to give your unique sound, because in the child class the cat is going to might be purr. Then you can just give your unique sound, and might be you want to have system.out.println, you want to give your some sound here, right? Okay, so what you're going to do is simply write the name, because the method signature is going to be exactly similar, right? Because we've got this method signature from the parent. What you have changed is the implementation, correct? So now what is going to happen is at runtime, okay, at runtime when objects are created, depending upon which object is going to be calling this create sound, that class's method will get called. Meaning there is a rule in Java, okay, if you have instance method means methods which are not static, in other words non-static methods, okay. And let's say you have this overriding, this is concept of overriding, because here in the child class you're actually overriding the implementation of what, the parent class. So when you have non-static methods which are overridden, okay, the version which gets called is depends upon the object, depends upon the of which classes object is actually calling it. Meaning suppose if I have animal, let's say we say a equal to new animal, right? In this case, what is the object created? The object created of this a is nothing but actually a reference, right? It is a reference of type animal which is pointing to an object of type animal, correct? This is where the object gets created. I can also say animal b equal to new cat. This is allowed because here my memory references of type animal and it is referring to a child object. It is possible, right? Because you can refer the parent reference can actually refer to a child object. So what is the object here? The object is of type cat. Now when I say a dot, let's say what was the method? Create sound. Now when I say a dot create sound, as per rule, that particular method gets invoked whose object is created. When you say a, this a is actually pointing to whose object? It's pointing to animal object. That means this create sounds, which version of create sound will be called? The version of create sound which is present in the animal class. In animal class, we have a version which simply prints the output as animal. So this is going to give me an output of simple on my screen. I'm simply going to get animal, right? Now when I say b dot create sound, now as you see, though the reference is of parent, but the object is what? Object is of the child. So which method or which version of create sound will be created? The version in which has been defined in the class cat, which is the child class. In this case, we have the word purr. So I am going to actually get here purr, right? So tell me, when was this, which version of the method create sound gets created? When was it decided? It was decided at runtime. Why at runtime? Because it depends upon the which object is created, and object creation always happens at runtime, right? So that is why method overriding, okay, is nothing but your runtime polymorphism. Why polymorphism? See, same names, but what we have is different implementation for the methods. Right? Hope that this makes sense. Let's just go to IntelliJ quickly and look at the sample code. So here I have the same classes. If I have a class animal, right? So I've just written here a constructor, default constructor, simply written that parent class constructor is called. The reason being, I also wanted to demonstrate that whenever a child class object is created, no, it is going to first call the constructor of the parent class. We'll be showing it shortly. Then I have a method which is called as void make noise, right? Here I simply written generic animal noise. Simple just print statement, just wanted to demonstrate the concept of overloading and overriding. Now I also have a static method void display message. So in this parent class animal, I have a constructor, I have a void make noise, and also have a static, method, right? So a instance method and a static method. Then we have a cat class, which is going to extend animal. That means cat is a child class of this. Again, I have a constructor here. If you see here, I have overridden the method void make noise, right? You can also see this symbol O, which actually says that this has been overridden, right? So it's also showing me a one override, right? So in the animal class, I had a same method signature void make noise. Now I wanted a different implementation for it. So I have overridden this value, correct? In the child class, what I have done this, for this make noise method, I have also performed overloading. That means I have performed compile time polymorphism by doing what? By changing the method signature. As you can see here, I can see I have changed the method signature by introducing one more parameter. This particular method version does not have any kind of input parameter, but the second version has input parameter. I have written a simple statement. Again, this also has a static method, right? So now let's look at the demo. This is where I've written the main function, right? So the rule which we saw is, if you are trying to call the, a particular method which has different versions, that means it has overridden versions, right? Which method gets called depends upon whose object is getting created, right? Whichever class's object is getting created, that class's version will be called in the runtime when it is method overriding, because that happens at your runtime. But if you are trying to do the same concept for static methods, then what will happen? We'll have to check. So let's go one by one. So I've created an object of animal class, right, which is our parent class. When I say animal dot make noise, now who's animal? If you look at make noise, let's go to make noise. If you see your make noise has a version in the animal class, correct? So basically I would want it to print generic animal noise. Why? Because I have created the object of animal. So when I run this, we'll show it to you. It will basically give me the output as generic animal noise. Now next I do is create the object of what? Of my child class. When I call make noise, right? If you remember, in the cat class, we had even done method overloading, correct? So when I say cat dot make noise, this at this time it is going to depend, determining based on my method signature that this particular method cat noise would be called. Why? The overridden method which is present in the child class will be called because we have created the object of the child class. So whatever version of child class has this make noise, that will be created. When I say cat dot make noise per, now this is going to be calling the overloaded method, right? Because we're done method overloading, right? After that, I've created a reference of my parent class and assigned it to the object of the child class. Here things get interesting. When I now call using this object dot make noise, this make noise will basically be called on the version which is present on the object. The object which is getting created is of the cat class. That means the version which is present in my cat class will be called. That means the overridden method will be called. Okay. Now, this is what we already know. Now let's go one step further. If you remember, there were two static methods. One, there was display message here, and the other static method here was again a display message, right? So when I do here, let's try to run this and see what we get. Okay, so because I had written, if you remember, in the constructors, I had written simple parent constructor call, right? So when the first time and I'm actually creating, an object, it's creating an object of the Parent class, a simpler parent class constructor is called, right? Animal dot make noise, generic animal noise, right? This is all clear. Then we're going to do object again. If you look at here, I have only created the object of the child class. But when you have a parent-child relationship, okay, in inheritance, no matter you have only called which constructor, you have just simply called the constructor of what? The child class. But Java internally is going to first construct the parent class constructor and then going to call the child class. And why is this so? The reason is, if we and when we think about inheritance, we always say that because you use this word cat extends animal, we say all the properties and all the behavior, that means the data members and the methods which are present in the parent animal will be available to cat, correct? If they have to be available to cat, that is only possible through objects, right? Using objects only we can actually access the data and also the methods. That means if I have to make all that available to cat, I have to first construct the object of my parent class. And that is why whenever you create an object of the child class, first internally it is going to first construct the parent class. That's why parent class constructor is called, followed by child class constructor. Now this is also a famous interview question where the interviewer asks you, if you have a parent-child relationship and you create an object of the child class, which constructor gets called? So first it's parent class, second is child class. All right. After that, because it is an object of the child, when you say cat dot make noise, you are going to get the overridden method which we saw. When you do cat dot make noise, it's an overloaded method. So you're going to call this, right? This is very fine. Now, when you do this, you are having what? A reference of what? Of the parent class, and you're calling what? You're creating an object of the child. Because an object of the child, new cat is where the object is getting created. That's why first parent class constructor is called, followed by the child class constructor which we earlier saw. Now when you say object dot make noise, this will now call the version which is present in cat, because if it is an instance method, okay, if you're overriding an instance method, the method which is present in your object class, that gets created. Okay, so cat noise, right? Now what I've done is I'm saying object dot display message, right? Now look carefully, object dot display message. This should, because if you see display message, okay, in both the classes were static methods, right? And what is static? Static means everything is decided at compile time. Because it is decided at compile time, tell me, will it depend upon the object created? No, because object is not created until runtime. That means if you have static methods, and let's say if you see here display message, this method with the same signature was present in the parent class also and was present in the child class also, correct? So when you say object dot display message, as it is, a static method, which version to call is dependent or decided on the compile time. And in compile time, you only know that the reference is of type what? Animal. That means the version of animal will be called. So you will see your display method from the parent class gets called. Correct? That means if I have to call the version which is present in my cat class, I have to call it by the reference of the cat. As you can see here, cat equal to new cat. Here I have actually reference of the cat type. That means if I call using this cat object, it is going to give me the display method from the child class. Hope this is clear. So two takeaways from this particular video is that one is, if it is a static or a static method, the method is being called depending upon the type of the reference, because which type or the which version of method to be called is decided at compile time. This is called as the type of the object or the reference of the object. Okay. Then if it is an instance method or if it's a non-static methods, then the version which gets called is depending upon at runtime, and it depends upon the kind of object you are creating. That is second thing. Two more things to remember. Overloading can happen only on number of input parameters, type of the data types of the input parameters, or a combination of both. You cannot overload based on only on the return type, or you cannot overload simply using the keyword static. Okay, so this is the entire concept of